Hello guys, today I'm just making a video on some basic insights on how to solve questions related to the topic energy change in a system. I know many of you guys have this topic coming up for exams, so hopefully this video can help you all in order to solve these type of questions. By the way, time codes will be in the description box below so that you guys can skip to any questions you guys like, and if you guys want to see the questions much more better, you guys can do that in the YouTube settings. And yeah, if you guys have enjoyed the video, please do like, share, and subscribe to the channel. It really helps a lot. Let's begin with the video. Alright, so question 1 states that a student investigated how much energy from the sun was incident on the Earth's surface at a location. So they're asking us to choose the most appropriate resolution for the thermometer that was used by a student. So you guys can see there's a nice little diagram over there. Usually thermometers will be having a resolution of about 0.1 degrees Celsius. So that's going to be your answer for about 1 mark. So we're going to leave it as it is. Your next question is that the energy transfer to the water was about 1050 joules, and we have to write down an equation which links both energy transfer, power, and time. So here I've drawn a little nice triangle that is called EPT, and that EPT is a nice way of putting it in a formula triangle is where you guys can see the formula much more clearly. So you guys can see that power is equivalent to energy transfer divided by time. So that's going to be your answer for about 1 mark. So do remember the formula. Now, next one is to calculate the mean power which is supplied by the sun to the water in the pan. So we're going to use the same formula where power is going to be equivalent to energy divided by time, which is going to be equivalent to energy, which is given in the question to be about 1050 joules. So we're going to use that 1050 joules divided by the time. Now the time here is mentioned to be about 5 minutes. And we know that 1 minute is equivalent to 60 seconds. All right, 60 seconds. So we know we have 5 minutes, so we're going to do 5 times 60 to give us a value in seconds, since time should be measured in seconds to convert your values in this case. So it's going to be 300 seconds. So you're going to have 300 seconds. It's going to be divided by that. So you're going to have 1050 divided by 300 to give you a value of about 3.5 watts. Now that's going to be your answer for, let's say, about 2 marks. So you're going to have 3.5 watts. Alright, let's move on to the next question. Now, the next question is to calculate the mass of the water the student used in her investigation. You have to use the correct equation from the physics equation sheet. So you've been given the specific heat capacity of the water. So you know that the energy, there's a formula in the physics equation sheet. By the way, you'll be given the equation sheet in your exam, so you guys can use that in order to understand the formula, where you have energy is equal to mass times C times delta T. Now delta T just represents the time it takes, that's all. Actually, it's just the degrees or the timing measurements. So the C represents the, what do you say, let's say the specific heat capacity, and the delta T represents the temperature change where it's increasing by, so it's going to be 0.6. So it doesn't represent time, it just represents the temperature change. So you know the energy to be about 1050. We know the mass is not given to us yet. We know the specific heat capacity to be about 4,200 joules per kilogram. So we're going to write that down. And we know the temperature change to be about 0.6. So you're going to mention that here, 0.6. Now all you need to do is to rearrange this formula to make M the subject of the formula. So that's a mathematical topic that you guys have to understand. So I'm just going to rearrange this on the right hand side, and we have M is equal to 1050 divided by 250, 2520. So we're going to get that value. I'm just going to use the calculator, guys. In this case, it's going to give me a value of about mass to be about 0.4166. Now that is going to be your answer for about 3 marks. So you have to maybe convert it to about, let's say, to 3 decimal places just to keep it fair. So you have 0.4117. So you have 0.417 kilograms. That's going to be your answer for about 3 marks. Let's move on to the next question. Now, the next question states that the student's results can only be used as an estimate of the mean power at our location. Now, give one reason why. That's just because the energy, if you have seen the diagram, is used to heat the metal pan. That's going to be a reason to heat the metal pan. For about 1 mark, you just need to mention that, or you can mention that there's an energy transfer to the surroundings through the insulation. The angle of solar radiation would have changed during the equation as well, or maybe the intensity of the solar radiation could have varied during this investigation. You can mention all those points for about 1 mark. Let's move on next question. Now, all objects emit and absorb infrared radiation. The best emitters of infrared radiation have dark matte surfaces, so you're going to mention that as well. I'm going to choose that. And the worst emitters of infrared radiations have light, shiny surfaces, all right? Light, shiny surfaces. So you're going to write that down. Now, the diagram 1 shows a sphere, which is at much higher temperature than its surroundings. We know that the energy is transferred from the sphere to the surroundings, so you guys can see that there's a table which shows us the readings for the sphere in different conditions, A, B, and C. And we have to mention in each of these conditions, A, B, and C, that the sphere transfers energy to the surroundings at different rate. So you have to put these conditions A, B, and C in correct order. So in order to analyze that, we have to see the temperature of the conditions, right? So you have the spheres in different conditions. So you have the greatest rate of energy transfer. That is going to be B. The reason is because the temperature of the sphere is in degrees as let's say it has actually the greatest rate of energy transfer is not much to the surroundings for B itself. Your middle one is going to be A. The reason is because temperature surroundings is pretty much in average better, but it has the lowest temperature of sphere in degrees Celsius. And your last one, which is going to be the least rate of energy transfer, is going to be C. Now the reason is because C has the highest temperature of the sphere in degrees Celsius and also the highest temperature of surroundings in degrees Celsius. All right, let's move on next question. Now give a reason for your answer. Now the reason is because there's the biggest temperature difference. It's going to be a biggest temperature difference of about 80 degrees. You're going to mention that of about 80 degrees Celsius for about 2 marks. All right, let's move on. Next question. Now, the next question shows us a can containing water. You guys can see that a student investigates how quickly a can of water can heat up when it's cooler than the room temperature. And we have to understand which can of water will reach room temperature the quickest. Give a reason for an answer. Now, the reason is because a can that is dark matte would be the best absorber of infrared radiation. So you can mention that, like I said, from the above points, a can that is dark matte, let's say, yeah, if it's this color, it's going to be the best absorber of, let's say, infrared radiation. That's going to be the answer for about 2 marks. So in this case, yeah. Let's move on to the next question. Now the next question is, apart from the material of the can, mass of the water, starting temperature, so just 3 control variables. So 3 control variables could be the shape of the can. So you have to have the same shape of the can, or let's say the same area of can. You're going to say that the same position in the room. You can mention that as well for this question. Or maybe the same surrounding temperature should be the same for all the cans, or you could say that there should be the same surface underneath the cans. Now the photograph shows 2 different foxes. You guys can see there is a fox A, which is in winter, fox B, which is in summer. Which fox is better adapted to survive in cold conditions? That is because it's fox A. This is gonna be A and B. So I think, yeah, this is fox A and B. The labeling is correct, yeah. So now fox A, because you can see it's winter, so you can and also mention that the ear sizes. If you guys can see closely, fox B has larger ears than fox A. Fox A has smaller ears. So you can mention that fox A has smaller ears. All right. And thicker fur. As you guys can see that fox B has no fur, whereas fox A is covered in thick fur and has, you can mention that it has thicker fur. That's your reason why it's going to survive. And you're saying the reason which fox will survive, because fox A is better adapted to survive in cold conditions because it has smaller ears and thicker fur. So that's going to be your answer for about 2 marks. But since this is 3, you're going to write, and these help to minimize energy transfers. Help to minimize. The spelling for minimize is correct, right? Minimize, yeah. These help to minimize energy transfer. All right, that's going to be answer for about 3 marks. So let's move on to the next question. Now, the next question is that when you transfer energy to a shopping trolley, the amount of work done depends on the force and the distance moved. First one's been done for you. You know that force is measured in newtons. You know distance is measured in meters. And you know that work done is measured in joules. That's going to be answer for about 2 marks. It's going to be Newton, meter, and joules. All right, let's move on to the next question. Now, the next question is the diagram shows 2 switches on a room heater. The heater has 3 power settings, and the power produced by 2 of the settings is given in the table. So you guys can see the power in watts. What is the power of a heater in kilowatts when switched to high power? So as you guys can see, that there's a difference of about, if you calculate the difference, it's going to be a difference of about 700 plus. So it's going to be a plus 700. So maybe according to a analyzing this question, maybe if we do 1,400 plus 1,400 watts plus 700 watts, since there's a difference of about 700, so you're going to get a value of about 2,100 watts. Since they want in kilowatts, we know that 1 kilowatt is about 1,000 watts. So we know that 2,100 watts is going to be in kilowatts. You're going to divide it, right? So you're going to have 2,100 divided by 1,000. Now this is going to give you a value of about, let's say, 2.1 kilowatts. That's going to be your answer. It's going to be equivalent to 2.1 kilowatts. 2.1. So that's going to be answer for about, let's say, for about 1 mark. So it's not high marks, but yeah, but it's going to be high marks once they add up together. All right, let's move on to the next question. Now, the next question is the heater is used at high power setting. It's switched for 1.5 hours. Calculate the energy transfer from the mains heater in 1.5 hours. Show clearly how you worked out your answer and give your answer in correct reasoning. So what you're going to do is, we know that 1.5 hours means it's going to be, let's say, 1.5 hours. So you're going to have 2.1 kilowatts times 1.5 to give you an answer of about, let's say, 3.15. So that's going to be an answer in the energy transfer. This time it's going to be in kilowatt hours. Now that is going to be your unit, kilowatt hours. So you have to give your answer and give the unit in energy transfer. So it's going to be 3.1 kilowatt hours. They accept kWh as well in terms of the answer as well. So it's going to be 3.15 kilowatt hours. Now, what is meant by device being very efficient? Meaning it doesn't waste energy in form of heat, sound, or light, depending on the device. So you can mention that most, let's say, most input energy is, let's say, usefully transferred. So you can mention that in this type of questions. All right. Okay, it's usually transferred, or let's say transformed. That's a better vocabulary in this case. Or you can mention that it doesn't waste energy at all, or most of the output energy is useful. That's also alright. Now the graph shows the temperature of a room changes during 1.5 hours, and that the heater is used. After 1 hour, the temperature of the room has become constant, even though the heater is still switched on. Now, give a reason why. Now, explain why is because the room, as you guys can see, the graph, a nice little graph here with temperature in the y-axis and time in the x-axis, is it's going, let's say it's stopping in a moment in about 1.5 hours. That is because the room is losing energy, or let's say heat. That's going to be an answer for 1 mark, but you have to mention 2 points as well, since it's 2 marks. It's losing energy at the same rate. You're going to mention that at the same rate as the heater. As the heater supplies it. So that's going to be an answer for about 2 marks. Let's move on to the next question. Now the next question, guys, I've noticed this question come up in, let's say, in the textbooks of Oxford AQA or AQA. It depends on, here you have to use good English when describing a vacuum flask. So you have to describe how the design of the vacuum flask keeps the liquid cool inside. You guys have to mention the uses of each one of these guys when describing them for about, let's say, I think it's maximum 6 marks. Yeah, you have to describe each one of those points. So what you're going to say is that the plastic cap, let's say the plastic cap is a poor conductor because of plastic, all right, inside because of plastic, and mention that because of plastic. That's going to be your 1 point. You're going to say that the glass container, that is going to be is a poor conductor, since glass is a poor conductor as well. It's a poor conductor of electricity, so reduces, or let's say, so stops energy transfer through conduction. Energy, you have to mention the points. Energy transfer, let's say, by conduction. And you're going to also mention that the vacuum in the flask, the vacuum, it causes it to stop energy transfer between two walls by conduction convention. So it requires, vacuum is necessary. The reason it's required, vacuum is required because let's say because both conduction, because both conduction and convection requires a medium. I'm going to mention that point as well. Requires, I'm just going to write it down a little bit. Requires a medium. I'm also going to mention the other parts of it. And the silvered surfaces are for poor emitters of infrared radiation. So these are some points that you guys can mention when dealing with the 6 markers. You guys can mention other points as well, silvered surfaces. But basically what I'm doing is I'm just explaining the uses of each one of these and why they're there as well. So you're going to mention that silvered surfaces help to reduce or stop energy transfer by radiation. That's also okay in this case. Now, next question is, you can see that Arctic foxes live in very cold environments. Again, how does the size of the ears help to keep the fox warm in a cold environment? The Arctic fox, or let's say Arctic fox, it has small ears. Arctic foxes have small ears, so it's a small surface area. You're going to mention that as well. So reduces, the energy transferred from the fox, right, to the surroundings as well. So that's going to be your points for about 2 marks. Let's move on to the next question. You guys can see there are 3 cups, and the energy is transferred through the walls of the cups by, you're going to mention that's going to be happening through conduction. In the air around the cup, the energy is transferred by convection. So that's going to be the answer for about 2 marks. It's going to be conduction and convection. Right, so now you guys can see that there's a graph again. It goes a downwards curve of temperature in the y-axis and time in the x-axis. What's the starting temperature of the water for each cup? The starting temperature is going to be roughly about 70. You guys can find it out from the diagram. So it's going to be 70. Now calculate the temperature fall of the water in cup B in the first 9 minutes. So roughly, if you take the scaling, it's going to be 2 divided by 10. If you take the scaling device, and it's going to be 0.2 per block. So for 5 blocks, that's going to be about 1, right? So 1, 2, 3, 4, 5. This is going to be roughly 1. So 1, 2, 3, 4, 5. This is going to be roughly 9. So for 9 in temperatures B, it's going to have a fall of about, let's say, of about 15, because you're going to have 70 degrees minus 55. If you see clearly, if you take the axis, it's roughly, let's say it's roughly reaching 55 there. So you're going to have 70 minus 55 to give you a value of about 15 degrees. That's going to be the fall of temperature of water in cup B in the first 9 minutes. Let's move on to the next question. Now, which cup A, B, or C has the greatest rate of cooling? You know that C has the greatest rate of cooling since it drops in temperature very quickly, more than the others. Okay, so you're going to mention that, give a reason using the graph, because like I said, it has the biggest drop in temperature. It's going to have the biggest drop in temperature during a given time. During a given time. That's going to be answer for about 2 marks. Let's move on to the next question. Now the next question is: the investigation was repeated using the bell shown in the diagram. Starting temperature and the volume of water were used. Draw on the graph in part B another line to show the expected results. So you're going to have a starting one at, let's say I'm going to draw on the graph. It's going to start at 70 and below the graph for C. So it must be a curve for at least like 8 minutes. So you're going to have a curve for about 8 minutes or more. That's also fine. So that's going to be your curve. It's going to be much more less than C. Let's move on to the next question. Now, after 4 hours, the temperature of the water in each of the cups and the bowls was about 20 degrees Celsius. So just why the temperature does not fall, let's say, below 20 degrees Celsius. Now, this is because that 20 degrees Celsius is room temperature. That's the reason why it doesn't fall. It's room temperature. Okay, let's move on. Next question. Now, the mass of the water in each cup is about 200 grams. You have to calculate the energy in joules transferred from the water in the cup when the temperature of the water falls by 8 degrees. Specific heat capacity of water is that. So you're going to have energy transfer is going to be equal to mass times specific heat capacity times change in temperature. They're going to have energy is equal to mass. Mass is usually measured in kilograms. So you have 1 kg is going to be 1 kg is going to be 1,000 grams. So you're going to have 200 grams. That's going to make it 200 grams divided by, let's say, 1,000 grams. That's going to give you a value in kgs to be about, let's say, 0.2 kgs. It's going to be answer. So it's going to be 0.2 kgs times C. Specific heat capacity will be about 4,200 times the time. It's going to be 8. It's going to be equivalent to 0.2 times 4,200 times 8 to give you a value of about 6,720 joules. 6,720 joules. That's going to be answer for about 3 marks. All I've done for the mass is I've converted it from grams to kilograms in order to do the calculation of energy transfer to get a value of about 6,720 joules. Now explain in terms of particles how evaporation causes the cooling of water. So you're going to say that the fastest particles, you're going to mention that the fastest, I'm just going to reload the system again. So you guys are going to mention that the fastest particles have enough energy to escape from surface of water. I'm going to mention mean energy from remaining particles increases. And you're also going to mention that the that's going to be answer. So you're going to say the fastest particles have enough energy to escape from the surface of water, and you're going to say that the mean energy of the remaining particles decreases. All right, let's move on to the next question. And you can also mention one more point, is that you're going to mention that there's a lower mean energy of particles. The lower the temperature, the lower the temperature of the water. All right, you can also mention that the speed for energy. So guys, this seems to be the end of all the questions. If you guys have enjoyed the video, please do like, share, and subscribe to the channel. It really helps a lot. And do comment below on what your thoughts are if you guys want me to continue solving questions related to past papers or related to topic-wise questions. And yeah, I think that's it. All right, bye guys.